Good morning, students. I am your science teacher, Shahin Miss. I welcome you all to K-Tech High School and Junior College. I hope, children, you all are at home and safe and taking all necessary precaution to prevent from this COVID. So, children, we are back with our online classes. So, today we will begin a new chapter. We will start with lesson number 13, Carbon, an Important Element, from Science Part 1. Okay, children? So, let's begin with the chapter. So, children, let me ask you something. What if we take some milk in an evaporating dish and heat the evaporating dish on a Bunsen burner? What remains behind at the bottom of an evaporating dish on complete evaporation of the milk? Have you done this, children? Or else, take some small samples of sugar, wool or dry leaves and plastic in a separate pan or a test tube and heat each of them. And what changes you can observe there? You can see a black substance remaining in this pan or test tube in which you do this, you heat it. So, this black substance is nothing but carbon. The element carbon is available abundantly in nature and occurs in free as well as in combined state. In this chapter, let us study the properties of non-metallic element carbon. The name carbon is derived from the Latin word carbo, meaning coal. Carbon is found in nature in free as well as compound state. Carbon in the free state is found as diamond and graphite, and in the combined state it is found as carbon dioxide and in the form of carbonates such as calcium carbonate, marble, calamine. Fossil fuels like coal, petroleum, natural gas. Carbonaceous nutrients like carbohydrates, proteins, fats. Natural fibers like cotton, wool and silk. So, the symbol of carbon is C. Atomic number, it is 6. Atomic mass, 12. Electronic configuration is 2, 4. Valency of carbon is 4 and it is a non-metallic element. So let us study in detail carbon. Okay, let's begin. What is allotropy? The tendency of an element to exist in two or more physical forms but with the same chemical behavior is called allotropy. Understood, children? Now, carbon, the allotropes of carbon are crystalline or amorphous form. Diamond and graphite are crystalline, while charcoal and lamp black are amorphous. So, allotropes of carbon are the phenomenon of existence of an element in different forms having different physical properties but identical chemical properties is called allotropy. Let's see the occurrence now. Elements can either be in structural crystalline form or may occur in a structureless amorphous form. Some elements like carbon, sulfur, tin, oxygen, etc. are found in more than one structural form. That is, some elements can have several structural forms while in the same physical state. These differing forms are called allotropes. Are you getting me? For example, in crystalline form, pure carbon is found as graphite, diamond, Buckminster fullerene, or else we can say fullerene. Diamond and graphite are chemically identical and consist of only carbon atoms. Atomic number of carbon is 6. Atomic weight 12. It is a normal element. Symbol of carbon is C. Valency, it is 4 and electronic configuration 2, 4. Now carbon exists allotropy. The crystalline allotropic modifications are diamond, graphite and Buckminster fullerene, or just we can say fullerene. Diamond. In diamond, each carbon atom is linked tetrahedrally to 4 other carbon atoms. Carbon-carbon bond lengths are equal to 1.54 Armstrong and bond angle is 109.5 degrees Celsius. There is a 3-dimensional network of strong covalent bonds. Properties are: they are colorless, transparent, crystalline solids. They are the hardest substances in nature with a refractive index of 2.4. They have high melting point because of strong covalent bond. They are bad conductor of electricity, that means no free electrons. They are inert allotropes of carbon. Let's see the uses now. They are used as gems for cutting and grinding hard substances. Windows for space satellites. To make high precision thermometers. To rectify cataract from eyes. Graphite. In graphite, each carbon atom is linked to 3 other carbon atoms directly in the same plane to form hexagonal rings. As you can see in the picture, the hexagonal rings. These rings constitute huge sheets or layers of atom. Carbon-carbon bond length in rings is 1.42 Armstrong. Are you getting me, children? Yes. Now let's see the properties. Steel grey crystalline solids with metallic luster. They are soft, slippery and soapy to touch. Marks paper black. They are good conductor of heat and electricity. Let's see the uses of graphite. It is used as a lubricant for making electrodes, as lead in lead pencils. We have seen this. To make refractory crucibles, to slow down nuclear reactions. Now the next is Buckminster fullerene. It is the pure form of carbon. Buckminster fullerene contains 60 carbon atoms arranged in a round molecule resembling a soccer ball. You must have seen a soccer ball, children. So there are large fullerene containing 70 to 500 carbon atoms. Fullerenes have been found to exist in interstellar dust as well as in geological formations on Earth. The amorphous allotropic modifications. They are wood charcoal, animal charcoal, sugar charcoal, lamp black and gas carbon. These are all in amorphous form, amorphous allotropic of carbon. Amorphous carbon, the black residue left behind when carbon compounds are heated in the absence of air. Wood charcoal, obtained by heating wood in a limited supply of air. It is soft, black, porous and floats on water. Uses. It is used in gas masks to absorb poisonous or foul smelling of gases. It catches fire easily because of low ignition temperature. It is also used as a decolorizing agent and as a reducing agent for making gunpowder. Animal charcoal or bone charcoal. It is prepared by the destructive distillation of bones, used as absorbent in purifying organic liquids for decolorizing raw sugarcane juices, as black pigment for rubber. Sugar charcoal, made by pouring concentrated sulfuric acid on sugar syrup. Sugar charcoal is a good absorbent in removing coloring matter from sugarcane juice. Lamp black. Now let's see. On burning substances rich in carbon such as turpentine, oil, etc., lamp black is obtained. Carbon papers, printer's ink, black paint, varnishes, shoe polishes, etc. are manufactured from lamp black. Gas carbon or coal. Gas carbon is formed during the destructive distillation of coal. Good conductor of electricity. Carbon electrodes and carbon rods are made of gas carbons. Let us summarize what we have learned, children. What is allotrope? Two or more than two forms of an element having different physical properties but same chemical properties are known as allotropes of an element. Such condition of element is known as allotropy. Have you understood, children, what is allotropy? Good. Allotropes of carbon. First is diamond. Diamond is one of the best known allotropes of carbon. It is useful for both industrial application and jewelry. It is hardest known natural mineral. Dominant industrial uses in cutting, drilling, grinding, diamond edges cutter and polishing. So this is about diamond. Next allotrope of carbon is graphite. Graphite, graphene to draw or write for its use in pencil. Unlike diamond, graphite is an electrical conductor, the most stable form of carbon. Graphite powder is used as a dry lubricant. A single layer of graphite is called graphene. So children, this was all about the allotrope of carbon, that is graphite. Have you all understood, children? I hope so. Let's see the next one. Allotropes of carbon, the next one is fullerene, Buckminster fullerenes or usually just fullerenes or buckyballs for short. These are molecules of varying sizes composed entirely of carbon, which take the form of a hollow sphere, ellipsoid or tube. Were under study for potential medicinal use, binding specific antibiotics to the structure to target resistant bacteria and even target certain cancer cells such as melanoma. So this was all about the fullerene. Understood, children? With this, we have come to an end of today's session. I hope, children, you all must have understood today's topic. Children, kindly watch this video carefully and attentively. After watching this video, children, please read the lesson for better understanding. We shall see you in the next video with a new topic. Till then, thank you, children. Take care.